Hi, I'm Tim, and this is the 6th video in the series about anti-gravity matter. This one is the second of 3 that deals with spiral galaxies. This video is only an overview. If you want more detail, see the anti-gravity matter document linked to the website. So this graph represents some of the first evidence for dark matter. This is Andromeda. And you can see that unexpectedly, the orbital velocity profile is fairly flat. In reality, there is no dark matter, and this effect is caused by a local reduction in the density of anti-gravity matter. Now, if you assume that the mass of normal matter in the galaxy is linked to its luminosity, and the objects in the disk are in a circular orbit, and G equals AN equals AA, then you can estimate the density profile of the AGM lacuna. And it looks something like this. And it is the density profile that you would expect from an AGM vortex, as was suggested in the previous video. So that's just confirmation that a flat orbital velocity profile is given by the sort of density profile that you would get in a vortex. But what about if you have a different density profile? What about if you have a flat-bottomed lacuna? Well, it turns out that the orbital velocity profile that you get from a flat-bottom lacuna is like this. Orbital velocity is proportional to radius. Now that's an interesting profile because in that situation, if you have two objects that are orbiting and they're arranged radially, they carry on being arranged radially. That means radial structures can survive and persist. So now we're moving on to spiral arms, and there are two mechanisms related to anti-gravity matter that create spiral arms. The first one is tidal spirals. In this simulation you can see that there are two star clusters orbiting each other. They generate a vortex of anti-gravity matter in the space between them. The vortex of anti-gravity matter generates a lacuna. The stars in the clusters are attracted to the lacuna, but tidal effects cause the two clusters to be stretched out to form spiral arms. Eventually, the stars in the clusters are delivered to a new rotating disk. But there is a second mechanism for producing spiral arms related to anti-gravity matter, and this second simulation demonstrates it. In the simulation, there is a simulated anti-gravity matter wind blowing outwards. The direction of the wind relative to the stars is like this. The stars in the disk feel drag because of the wind, but they feel less drag if they're in the lee of another star. That means that the stars tend to line up behind each other like cyclists in a peloton, protecting themselves from the wind. And the result is spiral arms. So there are two mechanisms for producing spiral arms: tidal spirals and AGM drag spirals. And here are some examples. The ones on the left are mainly AGM drag spirals. The ones on the right are mainly tidal spirals. So I've added an entry to the terminology list: tidal spirals and AGM drag spirals. Two mechanisms for producing spiral arms.